Okay, for what we have in number 7 is a differential equation that we cannot quite unequivocally separate the variables. But with the terms that we have present, okay, we will be able to utilize the integrating factor, and we have dy over dx for the derivative, and we have for our term in y, okay, we have y of first order. And now if I just work with the terms in this equation, so taking the commutative property of addition, with the left hand side we have x cubed dy over dx plus 2x squared y is equal to 1. And now before we get to the integrating factor, first of all we need to make sure there's no coefficient in front of the derivative. And in this case we have x cubed, and if we go ahead and divide this equation by x cubed, so we have, in rewriting, we have dy over dx, 2x squared divided by x cubed, when we have 2 over x times y, and that is equal to 1 over x cubed. Okay, and with the setup of this equation in the format, okay, we have for the integrating factor, we're going to utilize our coefficient of the y term. In this case we have 2 times the reciprocal of x. And so in the setup that we have regarding the integrating factor, okay, so in this one we have, going back to the natural logarithm base e, okay, we have to the integral of 2 over x dx, and that is equal to e to the 2 times natural log of x. And again, with conversion from coefficient to exponent, we have e to the natural logarithm of x to the second. And so for the integrating factor, we have at x squared. And if we go back to our differential equation, so multiplying these terms out, okay, we have x squared dy over dx, 2 over x times x squared, that's going to be plus 2xy. Then we have equal to x squared over x cubed, which will be at 1 over x. And for what we have on the left hand side, okay, we're going to have our terms will be the makeup of the product rule expansion of the integrating factor, which we have at x squared times the variable we are looking at solving, in this case at y. And as we near our destination, okay, solving for y, okay, we can move the brackets, and as we move the differential dx over, and here we have x squared y is to be equal to the integral of 1 over x dx. And for what we have in this one, we have x squared over times y is equal to the natural logarithm of x plus c. And for what we have in expressing what we have for y, okay, it's going to follow that y is equal to the natural logarithm of x plus c all over x squared. And you can also write this in terms of multiplication. We have y is equal to the quantity of the natural logarithm of x plus a constant times x to the negative 2.